And here we go. Right, so the study of trigonometry is really the study of triangles. That's what the TRI prefix is all about. But the reason why this is so important is that so triangles lead to trigonometric functions, and we're going to see that trigonometric functions are periodic, and they can be used to measure periodic things in the real world, like the temperatures of the various seasons and stuff like that. Anything that's cyclical, we can use trigonometric functions to model them. So that's why it's a pretty big deal, especially in the sciences. So we have to start somewhere. So before we start about triangles, we're going to talk about angles, and we'll say that an angle is really just a change in direction, as opposed to a change in magnitude. And even the more basic thing is a turn. You can think of it as a turn, and you can either turn clockwise or counterclockwise. Okay, and there's going to be an initial position and a terminal position from where you do this. So basically, you can think of an angle where it takes a certain line segment and rotates it around one of the points, and we get another line segment. Call the first line segment the initial side, and the second one is the last one is the terminal side. So we can see that. So we can describe an angle this way, where we have, say, if alpha is the angle, we can say alpha takes this line segment and rotates it into this line segment. And we do that. In this case, it would be counterclockwise. Or we could say beta is something that takes this and rotates it in the other direction, so it's clockwise into the terminal side. So either way, we're going to see that it is the terminal side in both cases would be the same, but we can see that they're different angles. They're sort of opposites of each other, if you will. Actually, they're not opposites, but they sort of complement each other in the sense that beta minus alpha would be just one revolution. In the same way that if we take alpha and then subtract beta from that, we get another revolution. So that's one way to go with this. So right now we're just going, as a convention, we allow clockwise to represent a negative direction or negative angle, and a counterclockwise to be positive angle. So that's just the convention. And one way we can think about this, we can, instead of just having these initial sides and terminal sides in a vacuum, we can actually put them, translate them into the XY plane, the Cartesian plane, and where the initial side will always be the positive x-axis, and then the terminal side is just where you rotate the positive x-axis to. Okay, this is what we call standard position, that to describe an angle, and we can also see that this is what we mean when we say that certain angles are in certain quadrants. So in this case, we would say theta is a second angle quadrant because this terminal side ends up in the second quadrant. Okay, and remember the quadrants, this is the first, this is the second, this is the third, and this is the fourth. All right, so now we want to talk about how do we measure, what units do we use to measure angles, and I'm pretty sure you've already heard of one of them, which is degrees. A degree is defined to be 1/360th of a revolution. But to be more precise, we want this a positive 1 degree would be a 1/360th of a counterclockwise revolution, because again, counterclockwise means positive. Probably the easier way to remember is just 360 degrees equals 1 revolution. Okay, and we see that in this case. So a 90 degree counterclockwise takes this positive x-axis to the positive y-axis, and 180 degrees takes this positive x-axis to the negative x-axis. 45 degrees takes the positive x-axis and rotates it halfway into the first quadrant. And the reason for that, of course, is 45 is half of 90. 135 takes the positive x-axis and rotates it halfway into the second quadrant, and the reason for that is from here to here is 90 degrees, and from here to here is 45 degrees. So the total is 135 degrees. 210 takes the positive x-axis and rotates it into the third quadrant, and it's basically from here to here is 180, and then from here to here is 30. Okay, and 30 is 1/3 of 90, so this is about 1/3 of the way into the third quadrant. Then negative 60, it's the same thing as positive 60, rotating it in the opposite direction, or rotating it clockwise. So negative 60 takes us into the fourth quadrant. And notice that we get this if we started here and rotated the through positive 300 degrees, we would end up at the same spot. Okay, so 300 degrees and negative 360, negative 60 and 300. They're different angles, and yet we're going to see they kind of end up in the same place. And there's going to be quite a few angles where as numbers they're different, but they in terms of the change of direction, they're basically the same. Okay. All right. So that's how that's one way to measure degrees. And then there's another one called radians, and we're going to talk about that in the next video.